Hey everyone, so solar panels are amazing, right? They're one of our best shots at clean energy. But they've got this one kind of ironic problem. And today we're going to dive into some really cool research that tackles this thing head on with a super clever solution to make solar power even better.
All right, let's just start with a big what if. What if a solar panel's single biggest weakness could actually become its new strength? I know, it sounds a little backwards, but just hang in there because this is where it gets really interesting.
This whole thing boils down to what we can call the solar paradox. It's pretty simple, really. The sun's light? That's the good stuff. It hits the panel and generates electricity, the photovoltaic effect. That's the whole point. But at the same time, the sun's heat, that's the bad guy in this story. It warms up the panel and actually makes it worse at doing its job.
So yeah, let's dig into this paradox a bit more. Because it feels a little weird, right? You'd think a super hot sunny day would be the absolute best case scenario for solar power. Turns out, it's not quite that simple.
Okay, so this is the real heart of the problem the researchers are trying to solve. As that solar cell is just sitting there, basking in the sun, it gets hotter and hotter. And as its temperature goes up, its ability to turn light into power actually goes down. We're talking a tiny drop in performance for every single degree it heats up. Now, that might not sound like a big deal, but trust me, over a long, hot day, that loss potential really adds up.
So, how in the world do you fix a problem like that? Well, this is where the genius of this research really shines. The scientists came up with this amazing two-for-one solution. And it's time to introduce the hero of our story, something called the thermoelectric generator.
So what is this thing? A thermoelectric generator, or TEG for short? Well, think of it as a super simple solid-state device. No moving parts, nothing complicated. Its whole magic trick is this. If you make one side hot and the other side cold, it just generates electricity. It literally turns a temperature difference into power. You starting to see where this is headed?
Okay, this is the really cool part, how it all fits together. Let's walk through it. Step 1. Sunlight hits the solar panel. It's making power, but it's also getting hot, right? Step 2, the researchers stick a TEG right onto the hot backside of that panel. Step 3, they add a heat sink, like the fan in your computer, to the other side of the TEG to keep it cool. Now you've got that perfect temperature difference the TEG loves. And boom, step 4, the TEG starts converting all that waste heat into extra electricity. And here's the kicker, the two-for-one part I was talking about. Step 5. By pulling all that heat away, the TEG is actively cooling the solar panel down, which makes the panel itself work better. It is a total win-win.
Now look, a great idea on paper is one thing, but you've got to prove it actually works in the real world. So that's exactly what the research team did. They moved from theory to practice to really put the system to the test.
And they were really smart about it too. They didn't just rely on one method. No, they did a two-pronged test. First, they physically built an experimental hybrid module, a solar cell with a TEG bolted on, to test it out. And at the exact same time, they ran a super detailed computer simulation of the whole system to double-check their results. That's good science right there.
All right, so this is it, the moment of truth. After all the theory, all the building, all the testing, did this hybrid system actually do any better? Let's take a look at the numbers.
So, the first thing they found was this really clear relationship. For every single degree Celsius they managed to cool the solar cell, its efficiency went up by about 0.2%. Now, I know, 0.2% sounds tiny, but think about how hot a solar panel gets on a scorching summer day. Those degrees and those little bits of efficiency, they add up fast.
And this is the big picture, the payoff. Look at this. The standard solar cell all by itself was chugging along at 6% efficiency. But when they added the TEG with just a simple air-cooled heatsink, the total system efficiency jumped to 8%. And get this, when they used a more powerful water cooling system, it shot all the way up to 9.6%. That is a huge improvement. They basically turned a 6% panel into a nearly 10% system.
And remember that two-for-one deal we talked about? This is the proof. That massive jump in efficiency wasn't just because the solar panel was cooler. Oh no, it was the solar panel working better, plus all the brand new electricity being generated by the TEG from heat that otherwise would have just been completely wasted.
Okay, so let's zoom out for a second and just wrap this up. What does all this mean? Why is a clever little system like this so important when we think about the future of renewable energy?
I think the researchers themselves put it best in their paper. They concluded that combining these two technologies could be, and I'm quoting here, very fruitful.
This isn't just some tiny incremental improvement, it's a genuinely new and promising path for squeezing more power out of every single sunbeam that hits the Earth.
So, what's the bottom line here? What should you take away from this? Well, this hybrid system creates this beautiful, virtuous cycle. First, it cools the solar cell, making it more efficient. Second, it generates extra electricity from heat that was just being wasted. And third, it takes the system's biggest weakness, all that heat, and turns it into a brand new source of power. How cool is that?
And that really just leaves us with one final big thought. This entire innovation came from looking at something we consider waste, in this case heat, and seeing it as a valuable resource instead. It really makes you wonder, doesn't it? What other forms of waste energy are all around us every single day, just waiting for the next clever idea to turn them into something useful?